Hello out there to you. In this video, we're going to do a regular monopoly is what they're calling this. It means it's to differentiate between a natural monopoly and just a monopoly like this. We know it's a monopoly because demand is out here, marginal revenue is on the inside, and so we're just going to answer some questions. So it says, what is a monopoly's profit maximizing price and quantity? That means if they choose a single price and quantity. When you see profit maximization in any microeconomics class, you're going to look for, and they're actually telling you this in this problem, but you're going to look for the quantity where marginal cost equals marginal revenue. So this is like the tool we use to make the most profit. And it works out. You can prove it in various ways. But anyway, so we look for, there's marginal cost, there's marginal revenue. They intersect right here. So the quantity is 20. And then we're going to mark up the price. I like that term, markup. So let's mark up the price. We want to charge the most that we can for those 20 units. So we're going to find that based on the demand curve. We're going to charge a price of 50. Okay, and that's our profit maximizing quantity and price. What is the monopoly's profit? So now we know that they're going to charge this 50. We just need to know how much does it cost them. So we find out the average total cost. So the fast way to do this is to find the average cost of producing those 20 units. So the average total cost of those 20 units is coincidentally 20. Okay, 20 rupees or pounds or whatever monetary unit you're using. So the price is going to be 50. The cost is 20, so that means per unit we're going to make 30. Per unit profit, I'm going to use pi as profit. Per unit profit is 30, and then how many units am I going to sell? I'm going to sell 20 units. So it would be, this is the quantity, this is the profit, this is sometimes known as marginal profit. So it would just be 30 times 60, which is 600. Okay, dollars, rupees, pesos, whatever you're using here. Socially optimal, okay, so this socially optimal tells you marginal cost intersects demand. This is sometimes, it has a couple of names. It might also call it the competitive equilibrium or the competitive price. Here it's saying socially optimal. Well, so we're just going to go where marginal cost equals demand. That's going to be a quantity of 30 and a price of 40. We use this because we're going to look at what the deadweight loss is, the damage to the market. So from the single price monopolist. So this red area that I'm shading in here, that's your deadweight loss. And if the curves are linear, that's pretty easy. You can calculate it as the difference between 50 and 24, which would be 26. And then we're going to multiply that by the lost units, which is 10. So that would be 260, and then half of that would be 130 is the deadweight loss if you were calculating that. And the regulator were to force the monopolist or monopoly to charge a socially optimal price. Would the monopoly still make a profit? The answer is yes, because the price is still higher than our average cost in this case. We can find that by going here and then find average cost. So they would still make a profit based on those units. And so it would be the distance between here and here, we don't know what that is, and then multiplied by that quantity, so we make a profit. That's reading regular monopoly graph and answering some profit questions. Or loss, if the average total cost was above demand, then we would be suffering a loss.